The most dangerous earthquake zone in America right now is not the San Andreas. It is not the 800-mile crack Hollywood turned into a disaster movie. The single most dangerous fault in the United States runs directly beneath one of the most crowded corners of the country, under the freeways, the water mains, and the bedrooms of the San Francisco Bay Area. It is called the Hayward Fault. And this year, the scientific picture of just how dangerous it is changed again. It has now been 158 years since this fault last broke, on a foggy October morning in 1868. The average gap between its major earthquakes is roughly 150 years. Do that math, and you understand why federal scientists keep using one word: overdue. When it broke in 1868, about 24,000 people lived nearby, and around 30 of them died. Today, nearly 2.8 million people live directly along that same fault line, and a United States Geological Survey scenario estimates the next rupture could kill roughly 800 people, injure 18,000, and cause $82 billion in damage. Today, we are going to break down exactly what is going on, where it is most dangerous, and whether things could get even worse. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you ever personally felt a real earthquake? Where were you? And what did it feel like the moment the ground moved? If you want to be first to know every time something major happens, subscribe. It is completely free. A thumbs up helps enormously too. Let us go for 5,000 likes on this one, so the algorithm shows it to the people who need to see it. Now, let us get into it. To understand why scientists are watching this fault so closely, you have to go back to the last time it let go. The date was October 21st, 1868. The time was 7:53 in the morning. A cold fog sat over the eastern shore of San Francisco Bay, the kind that blurs the hills and muffles the sound of a waking town. In the small settlements strung along the base of those hills, Hayward, San Leandro, Mission San Jose, people were doing ordinary things: lighting stoves, milking cows, walking to work along dirt roads. And then, with no warning at all, the ground moved. It did not start gently. Witnesses described a sound first, a deep, rolling roar coming up out of the earth, and then a jolt hard enough to throw people off their feet. The strong shaking lasted more than 40 seconds. 40 seconds does not sound like much when you read it. Try counting it out loud while imagining the floor beneath you heaving and cracking, and it becomes one of the longest stretches of time a human being can experience. Frightened people ran out of their homes into the streets. Cattle panicked and bolted across the fields. Fire engine horses tore loose from their harnesses and ran. And along a line stretching roughly 20 miles, from San Leandro in the north down to what is now the Warm Springs district of Fremont, the ground itself split open. This is the part that separates a Hayward Fault earthquake from an ordinary quake. The fault did not just shake the surface, it tore it. The two sides of the fault slid past each other by about 1.9 meters. More than 6 feet of horizontal movement in a matter of seconds. Roads that had been straight the day before were now offset, one half of the pavement shoved sideways from the other. Fences ended in midair. Cracks ran through fields in a nearly perfect line, tracing the exact path of the fault for anyone who cared to follow it. This was the moment the fault revealed itself, not as an idea on a map, but as a living seam in the earth that could move whole pieces of the world sideways. The town of Hayward took the worst of it. Nearly every building in the town was damaged or destroyed. Brick walls that had looked solid the night before came down in heaps of rubble and dust. A few miles north, in San Leandro, the second story of the Alameda County Courthouse collapsed entirely, a heavy stone and brick building folded in on itself by the shaking. And the destruction did not stop at the edge of the East Bay. The seismic waves raced west, straight across the water of the bay, and slammed into San Francisco. Here is where an old lesson was written, and then forgotten. Much of downtown San Francisco in 1868 was built on what people at the time called made ground. Land reclaimed from the bay by dumping soil and debris into the shallows to create buildable lots. That soft, waterlogged fill did something dangerous. It amplified the shaking. Where buildings anchored to solid bedrock swayed and survived, buildings sitting on the made ground shuddered violently, and brick and adobe walls cracked and collapsed into the streets. 5 people were killed in San Francisco alone, across the bay from the fault itself. In total, at least 30 people died across the region, and the damage ran past $300,000. An enormous sum for the time. To put that in context, this was the deadliest earthquake in the Bay Area's recorded history to that point. So destructive that for nearly 40 years it was simply known as the Great San Francisco Earthquake. It held that grim title until 1906, when a far larger quake on the San Andreas Fault took the name for itself. The shaking in 1868 was felt across an enormous area, from Monterey in the south to Red Bluff in the north, more than 300 miles apart. For days afterward, aftershocks rolled through the East Bay, keeping residents camped nervously outdoors, afraid to sleep beneath brick and timber that might come down in the next jolt. In a region of small towns and open ranch land, a death toll of around 30 was a tragedy, but a survivable one. The quiet, chilling question scientists ask today is a simple one. What would that exact same rupture do to the millions of people now living directly on the same ground? And something else happened in 1868 that mattered for everything that came after. It became the first earthquake in California ever studied scientifically. A geologist named Josiah Whitney led a systematic investigation, documenting the fault displacement and the ground effects, trying to understand what the Earth had actually done. Engineers of the day openly discussed the lessons, the specific danger of building on reclaimed bay mud, and a blunt warning to stop building the heavy stone cornices that could break loose and crush people in the street below. Those lessons were written down. And then, over the following decades, they were largely forgotten. By the time the 1906 earthquake struck, much of that hard-won knowledge had faded from public memory, and the city paid for it in fire and rubble. If you follow earthquake news at all, that pattern probably already rings a bell. A disaster strikes, the world learns exactly what went wrong, and then, one generation later, the memory fades and the same mistakes repeat. But here is the part that turns the 1868 earthquake from a history lesson into an active warning. The Hayward Fault has not gone quiet. It has not healed. It has been silently loading, day by day, for 158 years. And the ground it runs beneath is no longer home to 24,000 people. That changed fast, and it changed everything. So let us talk about why scientists single out this one fault, out of all the faults in America, as the most dangerous of them all. Because the honest answer surprises people. It is not because the Hayward can produce the biggest earthquake in the country. It cannot. The Cascadia Subduction Zone off the Pacific Northwest coast can generate a magnitude 9, an earthquake that releases more than 100 times the energy the Hayward is capable of. The San Andreas can produce a magnitude 8. On raw size alone, the Hayward Fault, capable of an earthquake around magnitude 7, does not top the list. The danger of a fault is not just about how hard it can shake. It is about three things stacked on top of one another: how big the quake can be, how many people are standing directly over it, and what the ground beneath those people is actually made of. And on the second and third of those, the Hayward Fault stands in a category of its own. Start with location. The Hayward Fault runs for about 74 miles through the East Bay, and it does not politely skirt around the cities. It runs straight through the middle of them. Its trace passes directly beneath Oakland, Berkeley, San Leandro, Hayward, Fremont, and up along the base of the East Bay Hills, threading through some of the most densely populated land in the western United States. Roughly 2 million people live close enough to feel severe shaking. In a very real sense, the fault does not run near the cities. The cities were built on top of the fault. Now, to understand what kind of fault this is, picture two enormous slabs of the Earth's crust grinding past each other, side by side. That is what geologists call a strike-slip fault. The Pacific Plate on the western side is creeping slowly northward past the North American Plate on the east at a rate of a couple of centimeters a year, about as fast as your fingernails grow. The Hayward Fault is one of the seams where that grinding happens. Most of the time, the two sides are locked together by friction, and the stress builds silently, like a spring being wound tighter and tighter. When the friction finally loses its grip, the spring releases all at once, and that violent release is the earthquake. And this is where a crucial distinction comes in, one that explains the entire danger of this fault. There is a real difference between magnitude and intensity. Magnitude measures the total energy an earthquake releases, a single number for the whole event. Intensity measures how hard the ground actually shakes at your specific spot, and that depends heavily on how close you are to the rupture and what you happen to be standing on. A magnitude 7 directly beneath your feet can shake you far more violently than a magnitude 800 miles out to sea. That is the Hayward Fault's whole threat in one sentence. It does not need to be the biggest earthquake in America. It only needs to happen exactly where the people are. But here is a strange and important detail about the Hayward Fault specifically. In many places, it does not stay fully locked. It creeps. The two sides slide past each other slowly and continuously, a few millimeters every year, with no earthquake at all. And you can actually see it happening with your own eyes. Curbs along certain streets in Hayward and Fremont are slowly bending and offsetting. Sidewalks are cracking in a clean diagonal line. Most famously, the University of California's Memorial Stadium in Berkeley was built directly across the fault, and the fault is slowly pulling the enormous concrete structure apart, splitting it year after year. This creep is proof, written into the pavement, that the fault is alive and moving right now. And it is a warning rather than a comfort, because the creep does not release nearly enough stress to prevent the big one. It just quietly confirms that the machine is still running underneath the streets. Then there is the third factor, the one that killed people in 1868 and will matter even more next time, the ground itself. To put it simply, not all dirt shakes the same. Hard bedrock transmits an earthquake's energy and then settles quickly. But soft, water-saturated mud and artificial fill, exactly the kind of ground that lines the edges of San Francisco Bay, do something far more sinister. They amplify the shaking, sometimes doubling or tripling how violently the surface moves, and they can even turn to liquid. Scientists call it liquefaction. During strong shaking, solid-seeming ground behaves like a thick liquid, and anything built on it, roads, pipelines, building foundations, can sink, tilt, or tear apart. Huge stretches of the bay shoreline, including areas packed with homes, freeways, and the runways of major airports, sit on exactly this kind of vulnerable ground. In 1868, it dropped brick walls in San Francisco. In 1989, during the magnitude 6.9 Loma Prieta earthquake, which was not even on the Hayward Fault, but more than 50 miles away, soft soil amplification and liquefaction helped collapse a double-deck section of freeway in Oakland and buckle part of the Bay Bridge, killing dozens of people. That was a distant quake doing that damage. The Hayward Fault would be centered directly underneath the city, so put the three factors together. An earthquake around magnitude 7, roughly 2 million people directly on top, and enormous zones of soft, amplifying, liquefiable ground. And you understand the exact phrase scientists use. The Hayward Fault is not the biggest earthquake threat in America. It is the most dangerous one. There is a real difference between those two things, and that difference is precisely why it sits at the top of the list. But here's where the numbers stop being geology and become human. In 1868, when this fault last ruptured, about 24,000 people lived in the East Bay, and roughly 30 of them died. The United States Geological Survey has stated the point plainly. The population now at greatest risk from a Hayward Fault earthquake is on the order of 100 times greater than it was in 1868. These are not just geological events. They are human experiences. And the scale of the human experience here has multiplied beyond anything the fault has ever actually tested. To understand what that could mean, the USGS and its partners did something ambitious. They built a detailed, scientifically grounded scenario of a magnitude 7 earthquake striking the Hayward Fault and traced its consequences hour by hour. They called it Haywired, a name chosen deliberately, combining Hayward with the idea of our wired, deeply interconnected modern society. Because the central lesson of the scenario is not really about the shaking on its own. It is about how everything we depend on is connected, and how a single fault slipping for a few seconds can pull all of it apart at once. The headline numbers are sobering. In the Haywired scenario, a magnitude 7 quake on the Hayward Fault results in roughly 800 deaths. It injures approximately 18,000 people, and it causes on the order of $82 billion in direct building damage alone, before you even begin to count the wider economic losses that ripple out for years. But the deaths and the dollars are only the opening of the story, because of that one word, wired. Consider water. Several of the major pipelines that carry drinking water to millions of East Bay residents cross directly over the Hayward Fault. When the fault slips several feet in seconds, those pipelines do not bend gracefully around the movement. They rupture. And that creates a horrifying chain reaction the region has seen once before. In 1906, the great fires that burned much of San Francisco to the ground were made catastrophic not only by the quake, but by broken water mains that left firefighters standing helpless with empty hoses while the city burned around them. The Haywired scenario projects hundreds of separate fire ignitions across the East Bay in the hours after the main shock. At the very moment the water system needed to fight them is most likely to have failed. Now layer on everything else that crosses that same fault line. Natural gas lines, electrical transmission, major freeways carrying hundreds of thousands of cars. BART, the rail system that moves the region's commuters, runs through a tube that crosses the fault. A single rupture does not cause one problem. It causes water failure and fire and transportation collapse and power loss and gas leaks, all cascading into each other, all at the same time, across a region of millions of people. That is what wired really means. In a modern city, the lifelines that make daily life possible are also the things that tend to fail together, each failure making the next one worse. And the damage does not end when the shaking stops. In the Haywired scenario, the strong main shock is followed by a long sequence of aftershocks, some of them large enough to bring down buildings already cracked and weakened by the first blow. Water service to parts of the East Bay could be disrupted for weeks, and in the hardest hit areas, for months. That is an almost unimaginable stretch of time for a modern city to go without reliable running water. Tens of thousands of people could be displaced from damaged homes, businesses shuttered, roads and rail lines severed, cutting whole neighborhoods off from help in the days when they need it most. As the aftermath of hurricanes Katrina, Sandy, and Maria all showed, recovery from a truly catastrophic event is not measured in days. It is measured in years, and sometimes in the slow, painful decision of whether a community rebuilds at all. There is also the brutal role of timing. The 1868 quake struck just before 8 in the morning as the region was waking up. A great deal about how deadly the next Hayward earthquake turns out to be will come down to something no one can control: the hour it happens. A rupture in the middle of a weekday would catch the freeways packed bumper to bumper, the schools full of children, and the office towers full of workers. A rupture in the dead of night would catch millions asleep in exactly the older, unretrofitted homes and soft-story apartments most likely to fail. Scientists cannot choose that hour, and neither can we. What planners can do, and what this kind of research is ultimately for, is prepare for the realistic worst case rather than the comfortable best one. Because the fault will not wait for a convenient moment. It never has. There is a difference between the Bay Area of 1868 and the Bay Area of today, and it is not only the number of people. California has some of the strictest building codes on Earth, written directly out of the lessons of past disasters. Countless buildings have been retrofitted, bridges have been strengthened. Hospitals have been rebuilt to survive strong shaking and keep operating when everything around them fails. All of that is real, and all of it will save lives. But the uncomfortable truth is that the effort is a race against a very old clock. Across the region, there are still hundreds of thousands of older buildings, many of them so-called soft-story apartments. Buildings with weak ground floors, often open parking tucked beneath the living units, that can pancake in strong shaking. Many critical pipelines and roads still cross directly over the fault trace, because there is simply no way to pick up a city and move it off the ground it was built on. Preparation reduces the toll. It does not erase it. And that is exactly why scientists keep watching and keep pushing people to get ready. So the question everyone asks is the one science genuinely cannot answer: when? And here we have to be completely honest, because this is where responsible science and internet fear part ways. No scientist on Earth can tell you the day, the month, or even the year that the Hayward Fault will rupture. There is currently no reliable method to predict the exact timing of an earthquake. It remains one of the hardest unsolved problems in all of science. Anyone who hands you a specific date is guessing, or worse, selling something. The fear should live in the facts, not in a fake prediction. What scientists can do is measure the odds, and the odds are what keep them awake. Here is what the record shows. The last 5 major earthquakes on the Hayward Fault occurred at intervals averaging roughly 140 to 150 years. The last one was in 1868. That makes it 158 years and counting, already past the long-term average, which is exactly why the word overdue keeps appearing in official language. The 2014 Working Group on California Earthquake Probabilities calculated a 33% chance of a magnitude 6.7 or greater earthquake on the Hayward Fault within 30 years. Sit with that. A 1 in 3 chance on this single fault within the span of an ordinary home mortgage. And a 2018 United States Geological Survey fact sheet concluded, in plain terms, that the fault may be ready to produce another earthquake in the range of magnitude 6.8 to 7.0. And the Hayward is only one of several major faults threading through the region. The same scientific working group concluded there is roughly a 72% chance of a damaging magnitude 6.7 or greater earthquake striking somewhere in the greater San Francisco Bay Area within 30 years. Somewhere, on some fault, the shaking is very nearly a coin flip within a single generation. And this year, that scientific picture sharpened again, which is the real reason this fault is back in the headlines. Scientists at Lawrence Livermore and Lawrence Berkeley National Laboratories used some of the most powerful supercomputers in the country to simulate 50 different possible magnitude 7 earthquakes on the Hayward Fault. Not a single hypothetical quake, 50 of them, each with slightly different rupture behavior, to map the realistic range of how the ground would actually move across the Bay Area, and to build a database that emergency planners and engineers can actually use. It is the kind of work that does not predict the future, but does something arguably more useful. It tells us, in fine detail, what exactly we are preparing for, and the results reinforce the warning rather than easing it. A dense population sitting on a loaded fault faces the potential for extensive, region-wide damage. And now we can see, block by block, roughly where the worst of that shaking would land. So what, exactly, are scientists monitoring right now? The Hayward Fault is one of the most closely watched faults on the entire planet. A dense network of seismometers records even the tiniest tremors along its length, the microscopic creaks and pops that hint at stress shifting underground. Instruments called creepmeters measure the slow, steady slip of the fault down to fractions of a millimeter. Satellite and ground-based sensors track how the land on either side is deforming, revealing exactly where the fault is locked and loading versus where it is quietly slipping. None of this can forecast the day of the next rupture. What it does is build the clearest possible picture of a fault under stress, so that when the ground finally does move, the early warning systems, the emergency planners, and the science are as ready as they can possibly be. Keep an eye on one more thing, too, because California has more than one clock ticking. Just this year, a separate study focused on Southern California modeled the enormous stress that has been quietly building on the San Andreas and San Jacinto fault systems, some of it accumulating for the better part of 1,000 years. The USGS has estimated roughly a 75% likelihood of a magnitude 7 earthquake striking Southern California within the next 30 years. The Hayward Fault may be the single most dangerous fault in the country because of exactly who lives on top of it, but it is not the only major fault in the state that scientists are urgently monitoring right now. So let us bring this all the way back down to the ground and separate the real danger from the movie version, because the difference matters more than almost anything else in this story. California is not going to crack off and fall into the ocean. The San Andreas is not going to yawn open and swallow Los Angeles. That is Hollywood, not geology. Strike-slip faults slide sideways past each other, they do not open into bottomless chasms, and no earthquake on Earth can drop an entire state into the sea. If that is the fear that has been sitting quietly in the back of your mind, you can set it down right now. It is not real. But here is the danger that is real, and it is quieter and far closer than the apocalypse on the movie screen. It is a magnitude 7 earthquake. Not the biggest kind, not a record breaker, just an ordinary large quake, striking a fault that runs directly beneath the homes of millions of people, most of whom have no idea it is there. That is the entire point. The Hayward Fault is the most dangerous zone in America, not because of the size of the shake, but because of who is standing on top of it when it finally comes. The real threat was never buried miles underground in some remote mountain range. It is hiding quietly, just a few feet beneath the ground that people are walking on right now, in one of the great cities of the United States. Scientists cannot tell us the day it will happen. They can only tell us that it is coming, and that the single smartest thing any of us can do is be ready before it does. So I will leave you with the question I asked at the very start, because your answers are genuinely the best part of this channel. Have you ever felt a real earthquake? Where were you? And what did it feel like the exact moment the ground moved beneath you? Tell me your story in the comments below. If this breakdown was worth your time, a thumbs up honestly helps more than you would think. Let us hit that 5,000 like goal so this reaches the people who need to see it. And subscribe if you want to be the first to know the next time the Earth does something it is not supposed to. Let us go. See you in the next one.